Good evening, everyone. Welcome to the Harvard-Smithsonian Center for Astrophysics Observatory Night. This is our last event of 2015, and we're going to get to cover one of, I think, is arguably the most amazing astronomical event of this past year in tonight's talk. Now, our reconnaissance of the solar system began in 1962, when the Mariner probe flew past Venus. 3 years later, we visited Mars. And in the 1970s, we launched 2 probes to the outer planets so that we could get close-up views of Jupiter, Saturn, Uranus, and Neptune. The last of them, Neptune, we visited in 1989, 26 years ago. But we left an entire region of the solar system unexplored. Pluto's home, the icy outer region called the Kuiper Belt. But not forever. In 2006, the New Horizons spacecraft was launched towards Pluto. It was the fastest spacecraft that we ever sent into space. And even traveling as fast as it was, it took almost 10 years to get there. And when it got there, it was moving so fast that it couldn't stay or go into orbit. It just had to make a single, fly past it and gather as much data as it could in one fell swoop. And not only did it have to gather all that data, but also it could not make observations and talk to the Earth at the same time. So for 24 hours, we had to wait and hope that the spacecraft didn't hit a moon that we didn't know was there and didn't have anything else go wrong. We had to wait until it was completely past Pluto and outward bound, and then hope that we would get this little faint chirp that said, "I'm okay." On July 14th, the evening of July 14th, we watched and waited here at the Center for Astrophysics, at New Horizons Mission Control, and around the world. And I know many people, including me, clapped and cheered and celebrated when we got that signal that we were all waiting for. Now, the data that New Horizons gathered is going to be trickling back to Earth over the next year. But already we have seen some incredible things and made some completely unexpected discoveries. What we have found is a world that is different from any other world in the solar system. It's a living world with its own unique geology. It is a world, dare I say it, that is fully deserving of the name planet. Tonight's speaker, Kelly Beatty, is a senior editor at Sky and Telescope magazine. He writes many of the feature articles and news items found in their magazine and on the associated website, specializing in planetary science and space exploration. He joined the staff of Sky Publishing in 1974 and served as the editor of Night Sky, a magazine for beginners, from 2004 to 2007. Kelly conceived and edited the new solar system, which is considered a standard reference among planetary scientists. And he was present at New Horizons Mission Control for the Flyby, so he can give us all the behind-the-scenes details. And now, Kelly Beatty.
Very much, Christine, and thank you all for joining us. She mentioned that the Neptune flyby by Voyager 2 was in 1989. How many of you remember that? So by one calculation, it's been 26 years, and by one calculation, about 40% of the American public has never had the chance to watch one of these space encounters where we discover a planet in our solar system for the first time. And that's what happened this past summer. That's why Pluto, in addition to all the history and lore and controversy surrounding it, it was a new world to explore. And so it's because of that, I think, that it has garnered so very much attention. And I'm here to tell you tonight that Pluto is every bit as exciting. Science reality is just as exciting as science fact. So let's get to it. First, a little background. We live in a solar system that may not be that much unlike a lot of other solar systems in our galaxy. And over there on the left-hand edge is the Sun for scale. These are all our main bodies to scale. So here are the 4 innermost planets. the 4 giant planets. Pluto's out here. And the point I want to make by showing you this is that all of these objects, the sun and all of those planets, came together at the same time 4.5 billion years ago from the same batch of stuff, the same batch of interstellar stuff. And yet, we ended up with, remarkably, all these various different worlds, kind of a zoo of planets. So let's kind of break it down just a little bit. We have what are called the gas giant outer planets, which have rocky cores, but they're surrounded by these deep shells of hydrogen and helium. I used to teach astronomy at a high school class, and I would tell the students, you know, if you don't know the answer to the question, if you say hydrogen, which is what these planets, or which comprises 90% of the universe, you have a good chance of having the right answer. And then we have these terrestrial worlds, which are unique in their own right. They don't have these envelopes. They have a rather different composition than the outer planets. And then there's a whole bunch of even smaller bodies. And I show you this to demonstrate a couple of things. First of all, Ganymede is the largest moon of Jupiter. Titan is the largest moon of Saturn. And both of those are larger than Mercury, which is the innermost planet. So as we get into this whole notion of what makes a planet, if these 2 objects were in orbit around the sun, we might well be thinking of them as planets. So we have Callisto, which is also Jupiter, Io, which is very volcanic. Here's our moon, and you work your way down, and here's Pluto at a size that's less than the moon and less than many of the other major satellites. And then there are the asteroids. Now, in the 1700s, a couple of theorists named Titius and Bode came up with a numerical formula that they thought described the distances of the planets for the sun. And here it is right here. It's actually pretty simple. So if you take this and you say 4 plus 0 is 4, divided by 10 is 0.4, Mercury is 0.4 as far away from the sun as the Earth is. 4 plus 3 is 7, divided by 10, 0.7. That's the distance of Venus. Earth is 1. 12 plus 4 is 16. Divided by 10 is 1.6. That's the distance of Mars. And as you work your way through, it very matches up very well with all of the planets known at that time out to Saturn, except there was a gap in this sequence between Mars and Jupiter. And so a bunch of astronomers in the late 1700s were following this progression. Uranus was discovered in 1781, and my goodness, it fit the pattern too. So it must be true. So they wondered ever more about this gap, and a bunch of them got together. At that point in time, much of astronomy was concentrated in Europe, and they met in a small conference room, all the major astronomers of Europe. They decided to find this missing planet between Mars and Jupiter. They called themselves the Celestial Police. I am not making that up. And so they set about to find this missing planet, and sure enough, on January 1st, 1801, Giuseppe Piazzi, looking from his observatory in Palermo, Italy, discovered an object exactly where it was supposed to be between Mars and Jupiter. Now, it turns out, and that came to be called Ceres, turns out that over the next couple of years, 3 more objects were found in that same general area. They came to be called Pallas, Juno, and Vesta. And then no more were discovered for quite some time. So astronomers of the day considered all 4 of those objects to be planets. And if you find a textbook from that era, you will see that along with Jupiter and Saturn and Venus and the newfound planet Uranus, those 4 objects are listed. That was our solar system. It included those objects. Well, by the 1830s, dozens of asteroids started to be discovered in that same zone. And astronomers came to realize that Juno and Vesta and Ceres weren't all that special after all. They were part of a belt of objects that we now know to be the asteroid belt that exists between those 2 planets. We've seen a bunch of those asteroids up close by spacecraft. Right now we have had various spacecraft go out. This one down here, this little tiny one, which is just a dot, we actually have a little sample of that thanks to the Japanese. And you can see that these are all the same size. Right now, our focus is on the largest asteroid Ceres. NASA has a spacecraft called Dawn, which is in orbit around Ceres right now. And it's been there for several months, and it's making amazing discoveries. But again, there are a whole different shapes and sizes. Okay, so those are the asteroids. That's our solar system. That's our celestial family, if you will. And now it's time to talk about that most distant member, Pluto, the little planet with the big moon. Okay, let's talk about Pluto. Now, I mentioned that Uranus was discovered in 1781. As astronomers studied the motion of Uranus around the sun, it takes 84 years to go around, has a very long orbit. They noticed that the orbit of that Uranus's motion wasn't smooth like it should be if it was following the rules of Kepler and of gravity. It would speed up and then it would slow down, and they wondered what was going on. Well, they hypothesized, two brilliant young mathematicians, one French, one British, ran the calculations and said the only thing that can explain this is that there must be a big planet out beyond Uranus that's creating a kind of tug on Uranus and causing it to speed up and slow down. The British mathematician was named John Couch Adams, and he was trying to get the attention of the Astronomer Royal, who was taking one of the extended vacations that the British like to take, I guess, or British astronomers anyway. The French mathematician, Urbain Jean-Joseph Leverrier, had an idea. He sent a letter to the director of Berlin Observatory, Johann Galle. That letter arrived 5 days later. It contained predictions of where the astronomers might find this mythical planet. Galle set to look for it that night, found it that night, 1 degree away from where Leverrier had predicted it would be. It was a triumph of mathematical prediction. Now, the interesting thing is that John Herschel, as early as the 1860s, had predicted that there would be a planet out beyond Neptune. One of the reasons was that when they looked at Neptune, which is a big planet, no doubt, and compared it with Uranus and the motions and stuff, they felt that there was still something missing, still a piece, a gravitational piece that was missing. And so in the early 1900s, two astronomers, Percival Lowell of Boston Brahmin fame, and William Pickering, each predicted that there must be yet another planet out beyond Neptune causing the tugs on Uranus's orbit. So they both made predictions. Lowell by then had established Lowell Observatory out in Arizona, ostensibly to look at Mars and to look at canals and such. But he took up this notion of this planet X out beyond Neptune. Now, the thing is, poor Lowell, he died in 1916 before his dream was realized of finding planet X. But the quest went on, and the astronomers that took over for him continued the search in the general area that he had predicted. And in fact, in 1928, they built a telescope specifically for conducting a photographic search for this planet X. And they needed somebody to run it. And who did they find but a young, impressionable farm boy from Illinois named Clyde Tombaugh. Tombaugh was only in his early 20s at that time. He lived on a farm. His family had moved to Kansas from Illinois. He was a prodigy when it came to astronomy. He built his own telescope. There it is over there on the side. There's some tractor parts in there. He was a very meticulous observer, and he'd sent his drawings to Lowell Observatory, and they were impressed, and they invited him to come out and aid in this search for Planet X. So at the young age of 24, he went across country, started looking for Planet X. This was the telescope that he used, and let me kind of explain the task in front of him. Lowell had made a prediction where to find this object, and because it's circling the sun, it should move against the background of the more distant stars. So Tombaugh's job was to, by night, take photographs with this telescope, and the photographs were big glass plates, about 14 by 17 inches, something like this. And Flagstaff, Arizona, which is where this is located, is a very cold place in the wintertime. And he froze his behind off during the nights, trying to stay awake and take all these photographs. And then about 3 days later, he'd go back and take photographs of the exact same area. And so if an object were cruising across the stars, it would show up as an object that had moved. In order to see this motion, Lowell had built what's called a blink comparator, where two of these plates, glass plates, would be mounted side by side, and then Tombaugh would look through this little eyepiece here, and a mechanical device would flip back and forth, showing him one image and then the other, and he would very carefully make his way comparing all the stars until his eyes were crossed. And he did that by day. And I don't know when he got to sleep. He did this by day. He was observing at night. One day in February of 1930, he walked into the office of the director, Dr. Slifer, and he said, "Dr. Slifer, I have found your planet X." Pretty brash. It's here on this picture. This is the discovery image of Pluto. Can you see where it is? Oh, by the way, it's not this. It's right there. All right, right on the edge of the frame. Right away, the astronomers, so it was true. And you know, this was the first, Herschel had discovered Uranus, Leverrier and Gale had discovered Neptune. This was the first discovery of a planet by Americans, first on a photograph. Lowell Observatory was very clever. They didn't really call it a planet. They kind of put it out there. The name actually came from an 11-year-old schoolgirl in England, in fitting with the other Roman mythology, named for the god of the underworld, right? So, Julie, that could have been you, right? Naming Pluto. And so it came to be known as the ninth planet. But right away, astronomers noticed that it really wasn't as bright as it was supposed to be. And, you know, was that really supposed to be tugging on the orbit of Uranus? It was quite a bit farther away. Using what we call an astronomical unit, which is Earth's distance from the sun as a kind of yardstick, Jupiter is 5 AU, or astronomical units away. Saturn is 10. Uranus is 20. Neptune is 30, and Pluto was 40 astronomical units away. Pluto was as far from Uranus as Uranus is from the sun. So there was some suspicion that maybe this wasn't the big gravitational object that they thought it was. And in fact, when they went back and looked at the calculations again, it turns out that there was no sort of leftover need for a planet. Uranus and Neptune were quite happy, thank you very much. It was just kind of an error in the calculations. There was no need for a Planet X prediction at all. And by fool luck, Lowell had kind of predicted where it was, and Tombaugh had kind of looked where Lowell's predictions told him to look, and there was an object. Now, Tombaugh didn't stop there. He ended up looking pretty much all the way around the sky, never did find another object anything like Pluto. This is Clyde Tombaugh later in life. He retired to Las Cruces, New Mexico. I had a chance to meet him a few times before he died in 1997. And this is the telescope that he built. He was a great guy. He loved to tell jokes. He actually came to Cambridge in 1987, along with his wife Patsy, and a close friend of theirs, David Levy, who was a comet discoverer. And they actually spoke here at Harvard. At the Smithsonian, but they didn't have a place to stay. So since I knew them and we'd become friends with them, they stayed with my wife Cheryl and me at our home in Chelmsford. And sure enough, when we sold that house, we put up a little plaque. You notice it doesn't say anything about Pluto's planetary status, but it's just that they had been there. Well, in any case, it was difficult to find out anything about Pluto in those early years. It was just a point of light, a very dim point of light, what astronomers call 14th magnitude, which is far, far dimmer than the naked eye can see, or even a pair of binoculars. But telescopes showed it, and over time, by just studying that point of light, in 1955, astronomers realized that Pluto's light was not constant. Over a 6.5-day period, it got brighter and then dimmer, and brighter and dimmer. And in fact, over time, you can see the two curves are different here. Over time, the amount of brightening and dimming changed. But what this meant was that Pluto was either the most enormously shaped football in the universe, with a big fat side and a narrow side, or it had bright and dark spots on its surface. And as it turned, sometimes we would see the dark spots, and so Pluto wouldn't look as bright, and sometimes we'd see the bright spots, and it would appear a little bit brighter in the telescope. Now, it was known from an early time that Pluto's orbit was not circular, and in fact was so misshapen, so egg-shaped, that when it was closest to the sun, it was actually closer to the sun than Neptune. How can that be? Won't they run into each other? Pluto takes about 250 years to go around the sun. And so every now and then, shouldn't they be colliding with each other? Well, it was realized that there's a kind of resonance of the two orbits with each other, an exact resonance, in fact. Neptune goes around the sun 3 times in the time it takes Pluto to go around the sun 2 times exactly. They're in what's called an orbital resonance. So this orbital resonance actually keeps them apart and keeps them from ever colliding with each other. So that was a good thing. We would like Pluto to stick around. There was still, though, we didn't know very much about Pluto itself. It was fainter than it was supposed to be. And, you know, we weren't really sure anything about its size or composition. But in 1976, Dale Cruikshank and some others used a new technology, infrared technology, to discover that there is methane ice on the surface of Pluto. This is the plot. This is the most complicated thing I'm going to show you. So let me walk you through it. This is the wavelength of light. This is all in the infrared. None of visible light here. This is in infrared wavelengths. This is how bright the object appears to be at any given wavelength. And so they step through, and you see the CH4s here. Those correspond to big dips where methane has a very strong absorption in infrared light. In fact, the reason that the planet Neptune looks blue to us is because there's so much methane in its atmosphere that it's absorbing big chunks of the red part of the spectrum and the infrared and reflecting the blue light. So these absorptions told Dale Cruikshank that there must be ice on Pluto. Now, why is that important? Because here are 3 dots showing Pluto, right, supposedly in a telescope. But the brightness of that dot could be because Pluto is small and very bright, or kind of medium-sized and gray, or very large and black. Before that discovery of methane frost, any one of these could have been possible. But methane ice is white. So Pluto had to be at this end. It had to be very small, much smaller than anyone had thought. All right, so it's small, but maybe it's, you know, a bowling ball with icing on it, or, you know, a giant cannonball. Maybe it's still really massive inside. Now, just a couple of years later, Jim Christie and Robert Harrington were working with the U.S. Naval Observatory, and they were taking a bunch of pictures. This time, late in the 1970s, was when we were launching the Voyager spacecraft to the outer solar system. And they were taking a bunch of photos of the outer solar system in support of that mission. This is a photo of Pluto, gigantically enlarged. And you notice there's a little lump on the side. And what Harrington and Christie realized is that sometimes the lump was on that side, sometimes it was on that side. It kind of moved back and forth. There must be a moon in orbit around Pluto. Now, we had something. Because if you know if you have something in orbit around Pluto, you know how far it is away from Pluto, you know how long it takes to go around Pluto, Kepler's laws tell you, therefore, how massive Pluto must be. That's the way it works. And it turns out Pluto was not very massive at all. It was not a snow-dusted cannonball in disguise. It was just a little small object out on the edge of the solar system. Now I want you to notice the angle of this orbit, because this is going to come back into play. Pluto and Charon do not orbit the sun like, you know, our moon does, kind of like this. They are orbiting on their side. And not only that, it came to pass that we realized Pluto and Charon are so close together that they actually face each other all the time. All the time. So our moon, one hemisphere of our moon faces the Earth all the time, right? Now imagine if one hemisphere of the Earth faced the moon all the time. That's what we have going on in the Pluto-Charon system. I said Charon, and that's important because the name for this object went to the discoverer, who was Jim Christie. Jim Christie had just gotten married. He was driving with his wife on their way to the in-laws for a holiday or a vacation, and he said to his wife, "I'm going to name that new moon after you, Charlene." And he realized later that, oops, I have to name it after a Roman god of some persuasion. So he went running to the encyclopedia in the dead of night. He woke up in the middle of the night. I promised my wife I'm going to name it after her. He went to all the mythology section, and there was a god named Charon, who was the ferryman to take souls to the underworld. So those of you who know the story now know that Charon is the name of the god with the hard K sound. That's true to the Greek. And if I hear you saying Charon afterward, you'll know that Jim Christie named the moon after his wife, Charlene, whose name is spelled C-H-A-R-L-E-N-E. Here they are last summer at the Pluto flyby. They're still around. They've been married a gajillion years, and they're still very much in love. And he corrected me. It's not Charon. It's Charon, like Charlene. So there you have it. Okay, well, all of this discovery had led us to the conclusion, this is a plot of possible mass. It's a log plot, so this is 10 times Earth, 1 times Earth, a tenth of Earth, and then this is the date. When Planet X was first hypothesized, it was thought, well, maybe it's as big as 10 times the Earth's mass. Over time, the discovery of Pluto, the methane ice, Charon, all of that, we now realize that Pluto is down here. It's 1/500th as massive as the Earth. There is no way it could have had any influence on any of those outer planets. But it still had planetary characteristics. As we came to know it and love it a little bit more, we discovered some things about it. In 1988, a group of astronomers from MIT went to watch Pluto cover up a star. As Pluto was moving in its orbit, it covered a star. It was predicted to cover a star, and the star first blinked out as it went behind Pluto, and then blinked back on as it came out from behind it. Now, in order to see this, they had to take an airplane equipped with a telescope looking out the side of the airplane and fly it over the South Pacific Ocean. Quite an undertaking. I was on that flight. I was there when the atmosphere of Pluto was discovered. And here's what I want to show you. Here's a trace of that star's light. If it were our moon instead of Pluto, this dip should have a very sharp edge. Blink, 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 like that. But you notice that it's got a gradual in and a gradual out, and there's some funny wiggles in there. That told them right away that there had to be an atmosphere around Pluto. Not only that, a few years later, using the now Hubble Space Telescope, Hubble took pictures of Pluto and found that it has spots. These are the actual Hubble images here, and then these are sort of reconstructions of maps of Pluto based on those images. Pluto has spots, and Pluto has color. It's not just black and white. It's got, the astronomers, this is again a reconstruction, but these oranges appear to be the real color of Pluto. Not only that, the spots seem to move around. This is a pair of Hubble images taken in 1994 and a decade later, and the spots have moved. Things are moving around. Maybe it's frost moving around, or maybe it's storms or something. I want to call your attention to this bright spot right here, which doesn't seem to be moving very much. That will play a role in just a few minutes. All right, well, Pluto was kind of well entrenched as the 9th planet in the solar system. And then in 1992, which is almost a quarter of a century ago now, something happened that started the talk. And that is that another object was discovered out beyond Pluto in the same general area. It was called 1992 QB1. It was discovered by a couple of astronomers who were out at the University of Hawaii, and it meant that Pluto was not alone. This looks a little busy, but it has always been speculated that out beyond Neptune there is another band of icy objects, not always, since 1950, that came to be called the Kuiper Belt, that are leftovers from the formation of our solar system. And then even far beyond that, there is something called the Oort cloud, which extends very, very far away from the sun, to more than 1 light year away. And in fact, I often get asked, what is the limit of the solar system? The Oort cloud is technically the limit of our solar system. These are objects that are bound to the sun. They extend roughly halfway to the nearest star, which is 4 light years away. So you could travel out into space for an entire light year and still be technically within the solar system. But in any case, the discovery of QB1, as we call it, told us that there must be other objects out there in addition to Pluto. Remember the story of Ceres and the asteroids? So here's an up-to-date plot dated yesterday, issued by the Minor Planet Center, which is in the next building over, or for some of you that are watching, it's in the building you're in. And all the red dots and white dots are objects in the Kuiper Belt. Here's Pluto and its position right now. And there are thousands of these objects. Those are the ones we found. We think there are probably billions of them, really, in the Kuiper Belt. And they are leftovers from the formation of the solar system. And so astronomers started to say, well, Pluto isn't really the smallest planet. It's really the largest member of the Kuiper Belt. It's not really a planet at all. The talk started. It was too small for planethood. And you know, they kind of had a case. Here's the Earth and Moon. Here's Pluto and Charon together. It was pretty small. Even though it had an atmosphere and spots that moved around, it was pretty small. And the talk got so bad that in 1999, the International Astronomical Union, hearing all the scuttlebutt, said, look, Pluto is a planet. It has always been called a planet. It's small, yes, but Pluto is a planet. So we're going to keep Pluto on the planet list. There are 9 planets, end of story. Clyde Tombaugh, actually, I mentioned that he came here in 1987. His nemesis in this Pluto isn't a planet thing was the late Brian Marsden. Right here, they met. I caught them shaking hands, took this picture. Notice Clyde's death grip here, right? They parted on friendly terms, I'm told. Brian was still looking for an angle, and he got it in 2005 when one of the objects in the Kuiper Belt was discovered that came to be called Eris. It turned out it was thought to be even bigger than Pluto. Now we got a problem. Because the International Astronomical Union is all about its committees, and they have one committee for naming objects that are planets, and they got another committee for naming objects that are smaller than planets, minor planets, comets, and so forth. And before they could figure out which committee to send this new discovery to for naming, they had to decide whether it was a planet or not. Now, if Pluto had been discovered at the same time as Eris, modern astronomers probably would have said, well, they're both not very big. Neither one of them is a planet. But if Pluto is a planet, and if Eris is bigger than Pluto, therefore Eris must be a planet. So you can see the issue. It turns out that there are a lot of big objects out in the Kuiper Belt. This is a comparative plot. Here's the Earth down below it. We now know, it turns out Eris is very slightly smaller than Pluto. The initial estimates were wrong, but the damage was done. There are others out there. You can see their names here. Some very large objects, some with moons, some not. The Kuiper Belt is a very busy place. So 9 years ago in Prague, astronomers met and they were going to decide whether or not Pluto's a planet. They were going to put it to a vote. They came up with a definition of what a planet was. They had an impassioned debate. In the end, they voted. I guess you had to have a yellow piece of paper in order to vote. And the upshot was this. They came up with a definition for a planet. And here's the definition. A planet is a celestial body that is in orbit around the sun. Well, I guess that means that all the planets we're discovering around other stars don't count, because it has to be in orbit around the sun. It has to have enough mass to be round, and that makes some sense. Now, when you pick up an everyday rock, that rock is not round, and that's because the rock has crystal strength, material strength, that's strong enough to overcome gravity's tendency to make it be a sphere. But when you get to be around 300, 400, 500 miles across, now you've got enough mass so that the gravity of your object, can overcome the material strength and kind of force something to be round. So the mass thing was kind of okay. But then they threw in this doozy, which was it has to have enough mass, again mass, to clear the neighborhood around its orbit. What the heck does that mean? Well, it's like this. I want you to all think back to your childhood days. You're out on the playground, and the school bully and his posse is making his way across the playground, right? He's mean, he's bad. Nobody wants to mess with him, right? So the bully's coming, and what do? You get out of his way, right? That's what clearing the neighborhood means. It means that an object has so much mass that it has the ability to perturb other objects, other smaller objects, out from that neighborhood in the solar system. That's what that meant. So the IAU definition created a new class of object called dwarf-planet, which they said was not a planet, it was a dwarf planet. That's another part of it I just don't understand. But in any case, one of these is a dwarf planet and one isn't. Which? Ceres or Vesta? Ceres, because it's massive enough to be round. Vesta is not quite round. It doesn't make the cut. Is this a planet or a dwarf planet? That would be a planet unless you moved it out to where Pluto is, and now it's got such a large volume of space to clear that it can't clear that space. It would not make the cut. So it's all about location. Another reason for being a dumb definition. Okay. Back to the star of our show. This is what you came to find out about. New Horizons, as Christine says, was launched in 2006. It got out of here in a hurry. Ordinarily, it should take decades to get from the Earth to Pluto, but New Horizons both was moving very quickly. And also, it flew past Jupiter about a year after its launch, and it got a tremendous gravitational boost. So here's a picture of the launch. My wife Cheryl and I went down for the launch. It was postponed 2 days. We didn't get to stick around, so we didn't get to see this. Too bad. On the way, it went past Jupiter. This is not the Great Red Spot. This is the Little Red Spot, actually. Took some pictures. This gave the spacecraft a chance to kind of test all of its instruments. You notice we got a volcano going off here on the volcanic moon Io, which I will remind you is the size of our moon and much bigger than Pluto. So, all right. So just before New Horizons was launched, astronomers realized that there are a couple of other moons around Pluto, small ones, besides Charon. They named them Nix and Hydra. And even after New Horizons was launched, so having more moons, that's good. That means you got more things to look at when you get there, right? But after New Horizons was launched, two even smaller moons were discovered that came to be called Kerberos and Styx. That was not good news. Why is that? Because all of these other moons are pretty big. Charon is pretty big. And you know, everything in the solar system gets beat up by things coming in and hitting it, right? Earth, moon, we all get hit by interplanetary debris. The other moons are big enough so that when something hits it and stuff gets scattered off its surface, it very quickly gets swept up. So, you know, very tidy in that way. But Kerberos and Styx were so small that when something hit them and scattered debris off of their surfaces, it never came back. And what that meant was there should be a ring around Pluto that we have not discovered yet, and New Horizons is flying right through that bullseye. So one particle is all it would have taken to knock out the spacecraft. Here's the trajectory as seen from the side. They looked and looked and looked. They didn't see any sense of ring. They had plan B, plan C, you know, if they needed to change course. They didn't have to do that. But what was happening is that they went by Pluto very, very fast. These time ticks are 1 hour apart. The little red dots are 10 minutes apart. And so Pluto is going to be there and gone in just an hour or so. Now remember, it takes Pluto 6.5 days to rotate. So as you're going by, you only get to see one side of it. Plus, it's spinning on its side, so much of Pluto is in darkness, and you're not going to get to see any of it. So what they did was they equipped New Horizons with a really powerful telescopic lens that could see Pluto with a lot of detail from far away. That way, they got a chance to watch Pluto rotate and take pictures of all the sides even before they got there. These are the various instruments that were put on it. Ralph and Alice are not accidental. They were named for the characters in The Honeymooners, yes. There's an experiment that was built by students at the University of Colorado, and it had one little extra package on board. It had a vial, a little canister full of ashes from Clyde Tombaugh, who had died in 1997. He didn't live to see the spacecraft launch. Patsy, his widow, did go to Kennedy Space Center and see the spacecraft launch. She died a couple of years ago. But Clyde got to see Pluto up close, eventually. Okay, so here we are. This is July of 2014, 1 year before the flyby. Already the spacecraft is showing Pluto and Charon orbiting separately, one around the other. That's a year out. Now we're talking 6 months to go. This is last January, right? Here's last April, 3 months to go. We're starting to see some detail on Pluto. And what I want you to notice is that Pluto is wobbling, right? Pluto and Charon are kind of like a double planet. They are close enough in mass that the balance point between them in terms of their gravity is actually outside of Pluto. So it's kind of like playing Ring Around the Rosie, right? That center point, Pluto is going around that center point too, and that's why you see that moving. All right, we're getting close. Here we are, just 3 weeks to go. This is the spacecraft coming in, taking time-lapse pictures, and you can see already, right? Pluto, this is a little bit closer. Pluto has this orange color to it. Charon has no color to it. Astronomers from Earth weren't like sitting on their hands this whole time. They've been studying these objects. They were able to discover, for example, that Charon has water ice on its surface, but no methane ice. Pluto, you know, has methane ice and nitrogen ice on its surface, but no water ice. They are very, very different objects. Well, the big day came, flyby. Christine was here. I was down in Houston. Not Houston. I was down at Laurel, Maryland, where the Johns Hopkins Applied Physics Laboratory is. That was the control center. And this next thing is the countdown up till the moment when New Horizons was closest to Pluto. It's being led, the countdown is being led by Alan Stern, who's the principal investigator. And I want you to notice that they start the countdown from 9 planets. Very, very excited group of people there, let me tell you. Okay, so what have we found about Pluto? We found out something, even on the way in from great distances away, we could see this kind of heart-shaped feature. Remember I told you when I showed you the two pictures and I said, pay attention to that white spot? That's the white spot. They could see this heart-shaped feature from very, very far away. All right? They named that informally, none of these names are official yet, Tombaugh Regio, after Clyde. And I said they're all informal. That's a whole talk for another day. The mission team is having a big fight with the International Astronomical Union about how these things are named. This is how Pluto might look in natural color if you were flying by in your spaceship. This is an exaggerated view, which shows some of the color differences. This red down here, this dark black really does have a reddish tinge. There's a kind of orange paint up here at the polar region. Now, you know about the methane ice. When you take methane, which is natural gas, right? Many of us heat our homes with natural gas. If you irradiate it, cosmic rays and sun's ultraviolet light and other things, you break that apart and it recombines into creating larger and larger organic molecules, until you get to something that's officially called goo. And that dark goo is what is probably covering a lot of these equatorial regions and maybe painting the polar regions. We saw in the New Horizons photos that Pluto has a lot of craters. When you have craters on the surface, that means that the surface has been around for a long time, okay? The moon is covered with craters in most areas, and the areas that are smooth on the moon, the mare, have fewer craters because they were placed more recently than the rest of the moon. Now ponder this when you go home. Earth should have more craters than the moon does, but it doesn't. Discuss. Anyway, Pluto has a lot of craters. Pluto has a lot of craters, but there's this one area this is Tombaugh Reggie of this whole thing, and this one area has been nicknamed Sputnik Planum, after Sputnik, has no craters at all. So when you plot this all according to age, it turns out that the oldest areas on Pluto, it looks busier than it really is, follow the green line and the green laser. The oldest areas on Pluto appear to be about 4 billion years old. Now, the solar system is 4.5 billion years old, so these are like ancient terrains. There are some areas that maybe are 1 billion years old. Sputnik Planum, this area right here, 0 craters, is at most 10 million years old. Somebody laughed about a million years. 10 million years is nothing in astronomical terms. It's a small fraction of 1% of the solar system's age. For all we know, the area on Pluto where Sputnik Planum is could be active now. Why do I say active? Because the only way you're going to get rid of the craters in an area is to smooth it over. That's why Earth doesn't have a lot of craters. We have oceans, we have rivers, we have atmosphere and rain and snow, and I hope not very much snow this winter, that smooth away the craters like sandpaper and make them disappear. So in Sputnik Planum, we have an area that somehow is being resurfaced rather rapidly. In fact, when we got close-up looks at Sputnik Planum, it appeared as though there was a big slab of ice with no craters, not one crater on it. That was very large. Here's the scale, 20 miles. So this is roughly the size of New England here we're talking about. And that ice seems to be flowing. You can see some little swirls in here. Here's a spot where it's broken through and started to fill in a crater. This ice is on the move, like glaciers. Not only that, astronomers on the team have figured out that in this area is a concentration of nitrogen ice, methane ice, and carbon monoxide, CO, not carbon dioxide, carbon monoxide. You have to appreciate this place, Pluto, is very, very cold, right? It is very cold. It's, minus 400 degrees Fahrenheit cold. And there are very few gases that can be gases. There are very few things that can be gases at that temperature. Nitrogen is one of them, but even the nitrogen freezes out. So these glaciers, the stuff that are flowing, the stuff that we would consider like water, are these weird ices like nitrogen and methane ice. But there are mountains on Pluto. These are some pictures of, this is a picture showing 2 mountain ranges. These are about as tall as the Rockies. Right? They're more than 10,000 feet tall. There's a range here called Norgay Montes, which is the Latin word for mountains, and Hillary Montes. They were named after Tenzing Norgay and Edmund Hillary, the 2 explorers that were first to climb Mount Everest. These mountains are not made of rock. There's no rock on the surface of Pluto. It's so cold that water ice, everyday water ice, is so completely frozen solid that it serves the purpose of rock in terms of the geology. So these mountains are probably made entirely of water ice with maybe a coating of these other more exotic ices. This is some of the new data that was just released last week. There are 2 objects on Pluto. It's not really obvious here, but you can see this as a kind of a dark depression in the middle. And here they are. This one is pretty obvious. This one is not. But when you do a 3D, which the spacecraft was able to do, it became clear that these are very broad mountains that are tall, 2 or 3 miles tall, and they have a depression in their tops, at their summits. This is a very common volcanic landform on the Earth. Mauna Kea, the Hawaiian Islands, are very much like this. They're called shield volcanoes. And we think, the astronomers think, that at some point in its past, water erupted, a slurry of water or some kind of briny stuff. There's a chemical term called a clathrate, where you can have water that's way below the freezing point and still be liquid, slopped out onto the surface from down inside Pluto and formed these towering mountains. So we think. Here's another new result. This weird kind of snakeskin terrain. I have no idea what that is. There are pits all over some areas of Pluto, swarms of pits that might be caused by, I don't know. No, please try to think of this with a smile on your face. In a month or so, when everything is frozen solid around here, and there are snowbanks along the sides of the road, if you notice anything that's dark, like a chunk of rock or something, will be warmer than the snow around it. And so it will actually warm up the snow and cause a hole in the snow where that is. You might try this at home, all right? It's safe, I promise. And so when you have dark spots on the surface, whatever it might be, it could be a meteorite, for example, coming in, or maybe there's shifting going on and there's cracks and heat is escaping. We just don't know. But these swarms of pits seem to be there. We know Pluto has an atmosphere. We now know for sure that there is haze in that atmosphere. And that haze is so microscopic that it causes the sunlight passing through it to make the atmosphere blue. The exact same physical phenomenon that causes Earth's atmosphere to be blue, a process called Rayleigh scattering, causes the atmosphere of Pluto to be blue too. Try saying that fast 3 times. Pluto is a very dramatic place. This is one of the pictures. You can see the hazes in the atmosphere, many, many different layers. And this is just a dramatic, dramatic photo. This is Sputnik Planum here. This is Hilary Montes over here, and I think I have a movie. Oh, okay, this is a close-up of that, showing the just dramatic landforms. It is just an incredible place. This is a slightly enhanced color view looking across Sputnik Planum. I think we're going to take a little fly around and see what the place is like. You can see these cracks. This is telling us something about how thick the ice layer is. We see cracks like this anytime you get big glaciers, but there is like nothing here. You know, there's not even a Starbucks. Yet. But it's this broad, very featureless plain. Now and then there's a little streak or something, maybe a filled fracture. And we're going to go over Hilary Montes, that group of mountains that I told you about. Very rugged looking. Again, this dark area seems to be around the equator of Pluto quite a bit. Should be very rich in organic material. Again, these can only exist because water ice is poking up through the crust somehow. Okay, so that's Pluto. Pretty cool and amazing place. But then there's Charon, which is even more, I think. Charon takes the cake for me. Notice the difference in color. I told you about that before. You'll see some of this stuff in more detail. Charon's got this red cap, which originally they thought that maybe it was atmosphere escaping. Remember, there's methane in that atmosphere, escaping from Pluto, getting trapped on the pole of Charon, getting irradiated and turning red. Nah, that doesn't work. Because here's Pluto close up. Charon close up, sorry. I want you to notice a couple of things. There's this huge gash going through the equatorial zone. There's all kinds of look at this deep fissure along the edge here. Let's put some labels on it. That area that is reddish, this is a black and white photo, but there seems to be some kind of what we would say in geology structural control. It's not just a veneer. It's not just a paint job. The stuff seems to be gurgling up. The red stuff seems to be gurgling up from inside. So this is a close-up of that polar region. Just amazing. Now, sometimes you get a fresh crater with white around it. Sometimes you get a fresh crater with black around it. Sometimes you get a fresh crater with both. You know, it's just wonderful. Wonderful, rich geologic detail. It is no exaggeration to say that not one scientist on the team ever expected to see this much detail on the surfaces of Pluto and Charon. So we're going to do a little fly around there too. Down this canyon, and it's very deep, very wide, much, much bigger than the Grand Canyon on Earth. And over here at the end, we're going to see a big block, a kind of a mountain, sitting in a moat. Imagine a big chunk of Lindt chocolate sitting in a bowl of chocolate pudding, and it would create a little moat around the bottom. Okay? We have started coming up with names for these. These are all informal. None of these are official yet. Sulu, Kirk, Skywalker, Spock. Let's see if those stick, so to speak. All right, we're getting near the end here. Pluto, remember I told you about those 4 small moons. These are what they look like. Again, this is compared to Charon. They're very tiny. They're only 10 or 20 miles across, but I want you to notice they have these kind of lumpy shapes. And conceivably, getting back to the whole idea of why the orbits are on their side, astronomers think that Charon was formed when something really big hit Pluto, created an enormous splat. The splat went into orbit, and Charon collected from that debris, but it was powerful enough, energetic enough, to tip Pluto and the whole shebang on its side. And perhaps some of these small moons are like little clumps of leftovers that have come together. So this is a cute little animation. You know about the orbital periods of Pluto and Charon. These are how long it takes the other ones to go around. Hydra goes around in, I'm sorry, I take that back. This is how long it takes them to spin, not to go around. So Hydra spins in just 10 hours, right? 10 hours, but it takes it far longer than that. Oh, well, let me just show you. I want you to notice that Styx is rotating backward. It's what we call a retrograde satellite. Hydra is just spinning its little brains out there. It's just great. Okay. All right. So that's the Pluto system. We have only received on the ground 20% of the data from that spacecraft. The remaining 80% are still on board and are going to trickle back over the next year. We have not seen the excitement end yet. The team likes to think, it's like getting a birthday present every week. They get something new that's new and amazing. One of the things to watch for, this is a big result if it turns out, I mentioned that part of Pluto was completely in shadow during the flyby by sunlight, but it was very weakly illuminated by light reflecting off Charon. So if they can pull it out, we might see some detail on that backside of Pluto illuminated by Charon shine. In any case, in 1989, Voyager 2 went by Neptune. Our reconnaissance of the solar system was virtually complete. The U.S. Post Service issued a series of 9 stamps. For Pluto, they put "not yet explored." Now we can say that that stamp is obsolete. Pluto has been explored. The guy on the left is Alan Stern. He's the principal investigator. He has this bumper sticker on his car. Right? And I want to point out to you that July 14th, 2015 was 50 years to the day that we got our first close-up photos of the Martian surface by the spacecraft Mariner 4. To the day. 50 years. And it's been said by Alan Stern and the other scientists that in order to find an object, in a solid object, because the gas giant planets aren't solid, a solid object in the outer solar system with as much geology as Pluto and Charon have shown us, you have to come all the way back in to Mars to see a planet with that much geology. Now, our story isn't over yet. Pluto has gone, New Horizons has gone past Pluto. It's on its way out even further. And this mission was sold on the idea that it would go past Pluto and yet another object in the Kuiper Belt. And that object has now been identified. It's called 2014 MU69. That's its sort of official designation for the next few years. It's New Horizons. It's on its way out. It's going to go by that on the first week of January. I think it's even January 1st in the year 2018. So we have only 2 years to wait until we get to see with another, and this one is a lot smaller than Pluto. It's some tens of kilometers across. But what's interesting is that we now think that this object, because of its size, might be actually pristine. That is, our true leftover from the beginning of our solar system, frozen in time for 4.5 billion years. And we can't wait to see it. Thank you very much. I really think that science reality is every bit as exciting as science fiction. Let me see a show of hands. If somehow we were able to create a globe of Pluto that you could own, how many of you would like to have one of those? You taking notes, Peter? All right, thank you very much.
Q&A.
Yeah, Q&A. Questions?
All yours.
Go ahead, sir. Yeah. Did you? Oh, you're going to buy a whole bunch of globes.
I think you said there was about 80% of the yet to come back.
Right.
Some of that data is in the form of photographs?
Yes. Yes, absolutely. Yeah. Go ahead, sir.
I heard Clyde Tombaugh a number of years ago down in Philadelphia. He was spending the latter part of his life going around the United States giving lectures to raise funds for astronomy graduate students.
Yes.
He was a wonderful man, but he told a beautiful story. When he went to college, his parents only had enough money to pay tuition for the first semester and a one-way bus ticket to the college. And when he stepped off the bus, he realized he couldn't go back home. He had to make it. And I used to tell all my students I taught that when they became parents and grandparents, if they didn't want to see their children right away, they might want to give them a one-way plane ticket to University of Hawaii.
One semester, yes. Okay, well, I mean, you could do worse than Hawaii. Yes, sir, go ahead.
I'm curious, so first of all, fantastic presentation, and very curious, obviously, as everybody else is, about the additional data that's coming back. Why were we in such a rush to get there? Like, was there even I'm sure there was consideration of sending a mission that could somehow get into orbit? Or
Sure. So now I know you've never driven faster than 60 miles an hour before, but the faster you go, and if you have to stop, the harder you have to hit your brakes. When it comes to spacecraft, that's rocket power. So it takes a lot of rocket power to speed it up and a lot of rocket power to slow it down. There was it barely, we had to get it out of Earth's gravitational grip. We had to accelerate it to faster than 7 miles a second. And there was never any intention of going into orbit. It would have made the mission much more expensive and take much longer time to get there. So it was kind of a compromise from the get-go. And a little known story, that far from the sun, you can't use solar cell panels to collect the electricity. And so Pluto, the New Horizons spacecraft, is powered by the radioactive decay of plutonium.
Wow.
Which is not easy to come by. They don't sell it at Walmart last time I checked. And actually some of that plutonium came from Russia. And so a lot of delicate negotiation had to take place in the early 1990s in order to get all of the plutonium that would ultimately be needed for the New Horizons spacecraft. Anybody up here have a question? No, we'll come back down here. Wait, somebody in back. No, right there, go ahead.
So the deflections in the orbits of Uranus and Neptune, is that just caused by the mass of all the objects in the Kuiper Belt?
All right, so the question is, what about the deflections of Uranus and Neptune? Well, Neptune has no deflection, all right? It's fine by itself, but it is deflecting Uranus. And so the rest of the matter in the Kuiper Belt is A, not massive enough to cause a deflection, and that includes Pluto, and B, it's kind of spread out. So like it's whatever chuds there are coming from all directions kind of equally. So there's no gravitational effect due to that at all. And in fact, today when people create spacecraft trajectories and they're trying to figure out what the influence of the planets themselves will be on the flight of the spacecraft, they count all the 8 planets. They don't count Pluto. They do count Ceres. They count the sun, of course. So even Pluto is not massive enough to count when it comes to calculating spacecraft orbits. Sad to say. Yes, sir.
As New Horizons continues on its journey, is it collecting any new data that it will send back?
Oh, yes. Very good question. Is New Horizons collecting any new data as it goes on beyond? There are more experiments on board besides cameras. They have that student experiment, for example, is counting interplanetary dust that it encounters. And one of the hot areas in planetary science is that some of the dust that's coming through our solar system is not from our solar system. It's from interplanetary space. It also has detectors to measure the magnetic field and the plasma, the charged particles that are in that area around it. Sort of, the sun exhales kind of a wind that permeates interplanetary space out to Pluto and beyond, and these experiments are gathering really important data on that. Yes, absolutely. In the back.
Hi. Data transmitted back to Earth.
How are they transmitted back to Earth? So how are the data transmitted back to Earth? Radio wavelengths. But there's an antenna, kind of like a satellite dish, on the side of the spacecraft that concentrates the radio beam so it's going right at the Earth. And Christine pointed out, while it was going past Pluto, it wasn't pointing right at the Earth. It was down here taking care of business as Pluto went by. And only later did it turn around. And in fact, it was still in the middle of its intense data taking, and it turned around briefly and said, yeah, I'm fine. And then it went back to doing what it was doing without actually returning any data. So yes, and so as the farther it gets away, the more weak that signal will get. But we have plenty of power thanks to the plutonium, and we have plenty of that. Even though the radio transmitter is very weak, because it's so concentrated, it's getting just fine. It's a very weak signal, though.
Wow.
All right, sir, go ahead.
This might be kind of an opinion more than anything, but would you say that at this point the scientists and the scientific community is pretty set with the 8 planets now, or do you foresee in the future that everybody's going to say, "Oh, look over here, we didn't notice, but there might be a planet from there"?
Right. So are there 8 planets or 9 planets? Question, or maybe more. I've actually grown pretty comfortable with the concept of a dwarf planet as a class of planet.
Yeah.
I think Ceres is a really cool place. Eris is going to be a really cool place once we get to know it. Pluto obviously is a very cool place. And I'm very comfortable with the notion of these smaller objects. And you've seen like some of these satellites like Io and such are very, very interesting. So that's okay, right? But the Chihuahua is still a dog. Right? The Chihuahua. Our sun technically is classified as a dwarf star. We still think it's a star, and I think the definition ought someday to be modified so that dwarf planets are considered part of the family of planets. I actually say, I don't say the 8 planets, I say the 8 major planets to make a distinction. Yes, ma'am?
What characterizes the dwarf planet? Is it mass?
Yeah,
Is it
it's mostly
different
mass, right?
If
You saw a plot of, remember, Pluto is 1/500th
Yes,
mass of the Earth,
I wrote it
and
down.
Earth is, I'm trying to remember now, 1/400th the mass of Jupiter.
Okay.
All right. So if you had a plot of planetary masses, right? Oh, there's the big guys up here. There's the little ones here, and then Pluto's like way down here in Sirius. So there is really a void, and I think it's not an inappropriate way to distinguish based on the mass. Julie,
What do you think is a good definition for a planet?
what do I think is a good definition for a planet? Well, I think a planet has to be in orbit around a star, for starters. Okay. There are some objects the size of planets that we think are like floating through interstellar space and not attached to a star. I'm not sure what we would call those. Lost, maybe. But I think you have to be in orbit around a star. And I do think this notion of mass is a good way to make a distinction, because we might not know what these distant planets around other stars are like. We're trying very hard to discover that. But one characteristic we can determine pretty easily, even more easily than size in most cases, is their mass. And so I think the mass alone, at least for now, can be a good criterion. But I want to tell you a little secret. I sidestep that whole issue. I don't call Pluto a dwarf planet when I write stories. I call it a world. Because I think that's what it is. It's a place that we have discovered and has become known to us. And now it's got all this amazing stuff. I want to ski, Sputnik Planet, baby. Way in the back.
You said the Pluto probe is the fastest spacecraft that's ever been launched from Earth.
Yes.
How long before it's the furthest away?
Oh, that's a really great question. The question is, since it was the fastest leaving the Earth, how long before it is the furthest away? Well, the Voyagers and the Pioneer 10 and 11, they really have a really big head start. And more to the point, the Voyagers, especially Voyager 2, also went by Jupiter and Saturn and Uranus and Neptune. And in each of those cases, it went by on the side that gave it a little kick in velocity. So they are actually moving out quite quickly themselves. I haven't actually looked to see how long it would be for them to catch up. It's a really great question. I need to do a little math, but it's going to be quite some time, maybe even centuries, before they're equal. All right, we got time for about 2 or 3 more questions. Go ahead.
I was just curious. Thank you for the excellent presentation. I was just curious, with the data that you have now, is there anything from that that's led you to ask more questions about what you might want to do for the next space mission.
Oh, great question. So knowing what we found out, how might we do the experiments differently on the next space mission, and in particular to the outer solar system? I think that one of the areas that this mission could have done a little bit better is in the area of spectroscopy. We will have spectra, and that spectra will go out to, thank you, you reminded me of something that I asked the scientists about, the very same thing. The spectrometer on board goes through all the visible wavelengths and a little bit into the infrared to about what we call about 2 microns and stops. There's a major set of absorption bands at 3 microns out of range that are organic bands. They are telltale bands for organic compounds. We will not know for sure whether there are gooey organics on the surface of Pluto. And so I think infrared is the way to go. And unfortunately, we'll have other spacecraft like the James Webb Space Telescope that will be able to study Pluto in infrared from afar. We might have an answer to that question, but that's what I would have done a little bit differently. All right. Go ahead.
Earlier you mentioned, I believe, that the Kuiper Belt has billions of asteroids that we don't think we've found yet.
That's right.
So what is the probability that New Horizons, I mean, how do you know its path, its course, and it's not going to just get knocked out before we get the 80%?
Yeah, okay. Yeah, so the question is, how can, with so many objects, and I'm repeating this because the microphone for the web doesn't necessarily pick it up. How do we know that with all those billions of objects in the Kuiper Belt, how do we know that one of them doesn't have New Horizons' name on it? You know? And might collide? Well, in fact, it's just the other problem. We used all the resources we had, and we eventually had to call on the big guy, the Hubble Space Telescope, to study objects that were potentially along the path of New Horizons before we could discover one that it could reach with the fuel reserves that it's got. And some of you might have seen, you know, when you're retargeting, it pays to do the retargeting as soon as you possibly can after passing by Pluto. So just within the last 2 or 3 weeks, the spacecraft has done 4 maneuvers to redirect itself to this other object. Otherwise, it would have missed it by too wide a margin. And even then, it's going to be missing it by quite a bit. So, you know, space is a really big place. I want you to imagine, right, that I have just as I do this with kids all the time. It's wonderful. Imagine that I've got a globe of the Earth here, right? And that's the Earth. And imagine I have a softball to represent the moon. That's a scale model of the Earth-Moon system. How far apart should I put those 2 objects to be at the correct distance from each other based on that scale? It's astounding. It's 30 feet. And that's just the Earth and Moon, right? When you, even using that scale, Pluto would be a mile away at that scale. Space is basically empty. There might be billions of objects. If you thought the Kuiper Belt diagram was really interesting that I showed you, you should see the one showing all of the thousands of known asteroids that can come near the Earth. It looks scary, right? Because they're all concentrated in and around our orbit. In reality, they're quite far. One last call for upstairs. Any questions? No. Thank you all very, very much. Please come up.